you study physics very long, you've probably heard one of the greatest lies in physics, particle-wave duality. Now, to be fair, this came about in an honest fashion, but now it's just dishonest. In the 1920s and early part of the 19th century, it wasn't clear whether empty space, the vacuum, contained quantum fluctuations. Some people thought because of the Michelson-Morley experiment that it didn't contain quantum fluctuations, so the idea evolved that these wave-like properties were waves through nothing with no medium. And that's just not possible. Waves always have a medium. They always have a carrier medium. But now, especially since the Casimir effect was proven in the late 1990s, there's no excuse for people pretending that the quantum field doesn't exist and that the quantum field isn't the medium of the waves. But we still have people that are in denial. Some old-timers who were taught by their teachers long ago that there was no medium, no real quantum field, that it was just a mathematical abstraction. And so we still have this problem today where people continue to say, oh, there's wave-particle duality. And then teachers who are misinformed or ill-informed tell their young students about wave-particle duality, and the lie keeps perpetuating itself. And it has another part of the problem in that there were quantum field theorists in the early days who said, okay, there's no particle, there's no medium, but there is a quantum field, so the quantum field must be made of waves. So they came up with waves without a medium that actually formed the quantum field that is the medium. So you have non-physical waves supposedly being the physical medium of space through which everything propagates, which is total nonsense. But today, even in colleges, that's the way it's taught. And you hear it in the wave function, the wave function that. They talk about the wave function like it's what's physically real, rather than the wave function being a mathematical approximation of what's going on in the quantum field, which is what's really happening. And when I'm talking about waves and mediums, I like to point out a couple simple things, that boats don't have wave-particle duality, and bells don't have wave-particle duality. When a boat moves through water, it causes waves. And those waves are made of water. They're not made of nothing. The boat doesn't have waves of water mysteriously attached to the boat and part of the boat. And if we do a mathematical description of the water waves, we understand that the medium is water and the waves are made of water. And the same thing with a bell, except instead of water, the bell transmits sound through air. So the waves have air as the medium, and we look at particle interactions within the gas of our atmosphere through which the waves propagate. And so that's the way we really need to think about particles moving through space. As I show in here in this picture, if you have an electron moving through space, space, under the standard quantum field model, is composed of electric charge dipoles, particle pairs. Well, those dipoles will polarize with respect to the charge, and with a moving charge, they'll rotate. They'll rotate around. And the charges that are rotating, the dipoles that are rotating closest to a particle, will cause other dipoles to rotate. And so on, out and out to the field. And this creates a wave. And that's how waves propagate. That's what waves are in quantum field theory. The waves are made of particles, of dipoles. So particles cause waves in the quantum field, which is composed of dipoles. And the wave function is just a description of what's going on in the waves. The wave function is not itself a description of the physical reality of the particles. And now there's, like I said, there's this clique. You've got the wave guys and particle guys, and they always argue. The wave guys say waves don't need a medium. Waves can be non-physical and period out of nothing and yet have physical properties. And the particles say, no, you have to have particles in order to explain the physical properties of the quantum field and of the interactions. And for me, the tiebreaker is charge, or polarizability, as the case may be. And that if you have a point-like polarizer, you can't describe a point-like polarizer with a wave function. Waves are good at describing functions that are spread out in space, but not something that's point-like. So, to me, that's the tiebreaker, as I said. Electric charge requires point-like particles, and electric charge dipoles require pairs of particles. And as I said, the particle pair model, matter-antimatter pair model of the quantum field, gives us a model that requires pairs of particles. And so all my physics research is based on this particle pair model. And because I've been able to advance my understanding of the universe much better with the particle pair model than with the wave model, I'm very confident that the particle pair model is the way to go, not having a non-physical wave-like medium that you pretend is physical, making pretend physical waves through this pretend physical medium, which, as I said, is what people are taught in college these days, unfortunately. So, when particles move through space, they make other particles move. They don't make waves move. Wave functions do not collapse. Particles interact with other particles. And if you think about all the particle interactions that you hear about, even the two-slit experiment, if you think of it in terms of particles interacting with other particles, then it makes it much more understandable. And we don't have probability functions either, which I'll discuss in another video. And the Copenhagen interpretation is no good because it's based on the denial of the quantum field. Once you have particles acting with particles causing events to occur, then you don't have the probability of events that didn't happen. You don't have Schrodinger's cat. You have real particles doing real things, causing real results. And that's the way real physics works. And the wave-particle duality is a lie, which unfortunately leads to other lies because of the non-physical nature of the wave function interpretations that we have in quantum mechanics. That's not to say all of quantum mechanics is wrong. It still works just fine with the particle pair interpretation, or particle interpretation. Anyway, I hope you like my video, and if you do, please like, share, and subscribe. And I'm an independent researcher, so if you buy my books or if you want to contribute to Patreon, I'd really appreciate it. My books are shown here. I've got 2 books on quantum field theory and 1 on particle theory that I'll talk about in some upcoming videos. And I apologize for all the motorcycles making noise this morning. So, yeah, thanks for watching.